Hi, Assalamualaikum. I'm Nur Shulina binti Rahim, KH20047. So now I will present about our background for case study 1. So as we know, nowadays biomass steam explosion pilot plant is commonly used in industry, especially to produce pellets. So as we look at on the figure 1, the plant have a few basic equipment occurs in processing biomass, which are plug screw, reactor, dryer, and also cyclone. So the raw material, which is bark, is used to put in the feed, and then the finest shredding bark will flow through the plug screw and then reactor with controlling the pressure and also temperature to convert into steam explosion being. After it flow into the dryer and then enter from the cyclone twice to separate into gas and also solids. So the gas will release as exhaust.
Next, for scenario 1, plug screw failure leading to less biomass to the gasifier. So, for the description, a vital part of a biomass gasifier system is the plug screw that function to ensuring the consistent and complete flow of the biomass material into the gasifier tanks. Next, the plug screw provide efficient biomass material flow through the gasifier system while ensuring an optimal feeding rate through its control, rotation, and movement. To find the roots of the problems, we are using the 5 analysis, which is for the problem statement is plug screw failure leading to less biomass to the gasifier. So why did the plug screw fail? Because the plug screw splintered due to the high frictions. Then why was the high friction? Because the screw mechanism was not properly lubricated. Then why was the insufficient lubrication? Because the maintenance schedule lacked regular check for lubrication requirements. Then why was the maintenance schedule lacking? Because the maintenance protocol did not specify a detailed checklist for lubrication interval and quantities. Then why were maintenance protocol inadequate? Because the inertial equipment manual provide only limited guidance on a true maintenance schedule and specific lubrication requirements. So that's all for my part.
Okay, for the scenario 2, which is low steam supply leads to low conversions. Okay, actually for the description of scenario 2, presence of low steam supply basically happen in the valve in the reactor. So the orifice of valve function to control the pressure and temperature which not to be lower and exceeded. It means that it should control as optimal. But the issue appears when the selection of the valve of reactor is not suitable with the pressure flow. So the steam supply in the feed reduce and leads to the producing the conversion of product being low. So the factors of steam supply being issues of lower have been explained in the root cause analysis of 5 Ys.
Hi, Assalamualaikum. My name is Nurhusina and my number is KH20032. I will continue the presentation. This figure shows the root cause analysis 5Y for the scenario 2. So, firstly, why was there a low steam supply? It because of the pressure drop. The decrease of the pressure drop made the capacity of the steam supply also decrease. And secondly, why there are pressure drops? It because of the continuous leakage from the valve. The steam leakage from the valve made the pressure to become low and lessen the quantity of the steam to go through the pipe. And third, why is there the leakage from the valve? It is because of the seal of the valve worn out. This valve since deteriorate over the time. And then fourth, why is this worn out? As the process of the steam supply required a high temperature, then the valve that were exposed to this high temperature made the seals of valve worn out. And even more, if the material of seals were not selected correctly and the design choices were wrong, not suitable for the steam flow. Lastly, why is there a faulty design? Due to the improper selection of the material which result in inadequate control, it reduced the steam supply efficiency and also made the valve is worn out in a short time. And then that's all for me. I will continue with the next presenter.
Assalamualaikum, my name is Itina Ismaramati Hamidi. My metric number KH20039. So today I will present about the scenario 3, which is the clock of the first cyclone exhaust outlet. So for the description of the scenario, first thing first, we need to know the function of the cyclone itself, which is the function is use centrifugal force to separate the particles. So in the first cyclone, the separation of the moist gas from a solid material, and then it will go to the second cyclone, which is it undergo the solid and also gas separation, and then the cyclone, it will operate in the low pressure and a cyclonic rotation. So when the first cyclone exhaust are clogged, it will produce a high pressure on the system, and the result in leak, rupture and other mechanical malfunction. At the same time, it will trigger the safety concern. So to overcome this problem, the system need to operate within the recommended parameter range when designing the cyclone itself.
We continue 5Y analysis. First, why the clock on first cyclone is how? Because residue from biomass has accumulated. Why biomass residue accumulate at outlet? Because biomass particle effectively separate by the cyclone filter. Why biomass particle effectively separated by the cyclone filter? Because filter mass size not appropriate for the particle size of biomass particle create. Why filter mass size inappropriate? Because not taking in consider the difference in biomass particle size, but the mesh size was using theoretical calculation. Why differ in biomass particle size not take into account in calculation? Because calculation were made using average particle size, which did not account for the range of size produced by the biomass material through the system extrapolation process. That's all from me.
So for the conclusion of this project, there are three main values that contribute in the biomass steam explosion, which is the first one is a plug screw failure in the classification system, structural damage, lack of maintenance, and also irregular lubrication. And then the second one is a steam supply issue that occur due to the pressure drop, valve leakage, malfunctioning valve, and faulty design. And then the last one is a cyclone exhaust outlet clogged due to the biomass residue can cause the incomplete cycle and produce ash and also dust accumulation. So from this scenario, we can conclude that we can using a 5-way analysis to determine the root cause and factor that contribute to the failure, and at the same time improve the effectiveness of the process. So that's all from us. Thank you.